Good evening. Good evening, students. Good evening, all. Am I audible?
Good evening.
Yes. Okay, we'll start the class. So one by one they will join. It's not a problem. We'll start the class. So today's topic is permutation, combination, and probability. So today's placement class, we are going to discuss these topics: permutation, combination, and probability. Permutation. First topic, I will take it up. Permutation. So each of the different arrangements which can be made by taking some or all of given number of things or objects at a time is called a permutation. Otherwise, permutation of things means arrangement of things. The word arrangement is used to if order of things is taken into account. Thus, if order of different things changes, then the arrangement also changes. So permutation, if you remember here from these definitions, so selection and arrangement of the objects, elements, person, letters, like that you have to take it up. Okay, permutation is selection and arrangements, selecting the objects and arranging the objects. In general, we can give one example. So we take it up three letters, A, B, C, three letters. Take two letters at a time and arrange it. Take two letters and arrange it, two letters at a time. So what will be different ways you can arrange it? Always, so what will be the permutation from letter A, B, C? Take two at a time, two letters at a time. So that is from the letters A, B, C. We can take two letters in this manner. Different selection and arrangement. So that is the first one. You can take it as a B, one arrangement, BA, another arrangement. Next, so two. Next, AC, CA. So total four. Now, further BC and CB. So further two. So total six different permutation. Total six different permutation you can make. That is selecting the elements and arrange. Okay, A, B, B, A are two different arrangements, not same. Similarly, AC, CE, two different arrangements. Next, BC, CB, another two different arrangements. So total six different arrangements you can make it from the given word A, B, C. So selecting the elements and arrange it. Okay, that is called the permutation. So here it is denoted by the formula generally NPR. NPR otherwise denoted as a P of n comma r. That is n factorial divided by n minus r factorial. So number of objects that is denoted by n, and picking that less than the number of. Otherwise, take all the objects. Okay. So that is r should be less than or equal to n. Less than or equal to n. R should be less than or equal to n. So that is a factorial. We all know that. So that is n factorial divided by n minus r factorial. So n factorial means, for example, if you take up some particular number, that is 5 factorial. 5 factorial means 5 into 4 into 3 into 2 into 1. Like that you can take it up, and keep it in mind 0 factorial is not 0. 0 factorial is 1, and 1 factorial value also 1. So that values keep it in your mind. So we'll see a few more examples. Before that, one more concept relevant to this, I mean the permutation. The number of permutation of n things taken all at a time, out of which P are alike and are of one type, Q are alike and are of second type, and rest all are different. So we are picking all the objects. So n different objects are there. I mean n things are there. In the n things or n elements or n objects or n persons, otherwise n letters, whatever it may be. In that sum of letters, I mean few letters or some objects are alike, same group, same, similar. Okay, so for that, the permutation will be n factorial divided by p factorial into q factorial. So p particular number of objects are same type. Q particular objects are same type in the total number of objects again. Just to see that example problem, there are 5 red, 4 white, and 3 blue marbles. Marbles, otherwise like a ball, you can take it up. So there is 5 red, 4 white, and 3 blue marbles in a bag. They are drawn one by one and arranged in a row. They are drawn one by one and arranged in a row. So assuming that all the 12 marbles are drawn, determine the number of different arrangements. Okay, total we have 5 plus 4 plus 3, so that is 12 marbles. Okay, so take it up like balls. Okay, different colors, red marbles, white and blue. Okay, blue, this all on the back. Take one by one and arrange, take all the marbles. In that 5 red marbles are same type, 4 white marbles are same type, I mean same color and same size. Okay, that is the meaning of this 5 red, 4 white, and 3 blue marbles, and arrange it in a order, in a row. So how many different arrangements, I mean how many ways you can permutate it? So that is 12 factorial ways we can arrange it. So that is some of them are repeated, similar one. So that is using the previous formula. There is n factorial divided by p factorial into, sorry, p1 factorial into p2 factorial into p3 factorial. So the formula given as p factorial, q factorial. So here in the given number of objects, 3 objects are similar. Okay, 3 different objects are same. So that means 5 red marbles. So that is P1 equal to 5, P2 is equal to 4, and P3 is equal to 3. Like that, you can extend the formula. So that is 12 factorial divided by 5 factorial into 4 factorial into 3 factorial. So for this, you can find the value. That's not a big issue. So that means how do you find the value? So 12 factorial means that is 12 into 11 into and so on 1. Similarly, other values in the denominator also substitute, and numerator denominator simplify, and simplify the value. You will get some constants. Okay, so that way we can identify the value. So that is one type of problem in the permutation. If similar kind, the objects are coming, then what will be the permutation? So in this manner, we have to find the value. So the number of permutation of n different things are at a time when each thing may be repeated any time of times is called the n power r. So n different things are given. Take r at a time when each thing may be repeated any number of times. May be repeated any number of times. So for that, the permutation is n power r. N power r. Example problem. Just see that in how many ways 5 apples be distributed among the 4 boys. Among the 4 boys, there being no restriction to the number of apples each boy may get. Okay, there is no restriction. So 5 boys share to the person 4 boys. There is no restriction. Okay, there is no restriction. So one of them may get 2 apples or 3 apples. Other may not get a single apple also. So for that, the permutation is 4 power 5. So total 4 boys, 5 apples are there. Share it any order. All the 5 apples may be given to one person. That is one kind of permutation. Okay, all the 5 apples may be given to one boy. Remaining no apples share. Like that, also you can permutate it. So that is the case in this problem. So for that, the different number of permutations are equal to 4 power 5. So that means 4 into 4 into 5 times you have to multiply 4. That is the value. Right. Inform to your classmates. Class started. Those who are interested may attend. Okay. So inform your classmates to attend the class. Next, so few more different possibilities. Just like that, we may not expect direct problem. Some additional information, some restriction may be given in the problem. So for that, for those kind of cases, what will be the different case of the problem? I mean permutation. So number of permutation of n different things taken R at a time. Then the particular thing is to be always included in each arrangement. It's nothing but R into n minus R, P R minus 1. Okay, so I mean not R, that is 1. I mean in the n different objects taken R at a time, in that particular thing, particular one thing, okay, one object or more objects also you can take it up. So here particular object should be there in the selection always. So here this one is given or particular objects are there. So that means n minus r divided by p n minus r. So that will be the permutation. Okay. If you take it up as a 1 means 1 into n minus 1 p r minus 1. Okay. So total number of n objects, take r at a time, r number of objects. One particular object is compulsory there. For that, how many different ways of picking one particular object? So there is nothing but 1. So 1 into n minus 1 p r minus 1. In particular case, 10 objects or 10 persons are there. The 10 objects take one particular object should be there always in the permutation. Okay. So remaining, okay, we are going to pick 4. So in that 4, okay, out of 10, picking 4 objects. In the 4 objects, one person compulsorily there. So that means what? So you have to take it up that particular object, omit it. One way you can choose that particular object. Remaining objects you have to choose. Remaining 3 objects from 9 you have to choose. So one way you can select that one. So remaining 3 objects from 9 you have to choose. So that is 9p3. So 1 into 9p3. That is a particular case of the first one. So number of permutation of n different things are at a time. So yes, particular things are to be always included in each arrangement is s factorial into r minus s minus 1 into n minus s into p r minus s. So yes, particular object should be selected in that manner. So corresponding permutation will be s factorial into r minus s minus 1 into n minus s p r minus x. So that is the extension of the first one. So number of permutation of n different things taken R at a time. When a particular thing is never taken in each arrangement, never take it in the arrangements. That is omit that particular object for the selection. That is the thing. So if it is only one object, we can make it as a n minus 1 PR. If it is 2 particular objects, you can make it as a n minus 2 PR. Right, you can take it up. So number of permutation of n different things taken all at a time when m specific things always come together. M particular objects always come together. For that, permutation will be m factorial into n minus m plus 1 factorial. So out of n different things, if you are going to select a particular objects, m particular objects, I mean take all the objects together, but in the arrangement when you make it, all those objects are together. So that is m factorial into n minus m plus 1 factorial. There is a case. So that is the next one. Number of permutation. That D1 is okay. Some letter of the word where vowels are together. Certain number of vowels are together. For example, if you take it up different, the word different. D I F F E R E N T. In that letter of the word, take, arrange in a different manner, but in the different arrangements, vowels are together. So the word is what? D I F F E R E N T. So in that, how many vowels are there? So first vowel I, then E, then E. So 3 vowels are there. In that, 2 vowels are repeated. So anyway, so we can take it up. That is 3 vowels. They are together. I, E, E. So when you form it new word with or without meaning, with or without meaning. So that is 3 factorial divided by 2 factorial. That is a repeated case. So that is into n minus 1 plus 1 factorial. So anyhow, detail we will see it in the problem. So just like that, yeah, we may explain, you may get confused. So these kind of problems are there in the example. Surely we'll see. So next, number of permutation of n different things taken all at a time. When n specific things are never come together. N particular things are never come together. So that is without any restriction permutation. There is n factorial minus n factorial into n minus n plus 1 factorial. That is the case. And next circular permutation of the n different things, that is n minus 1 factorial. Circular permutation, circular, what is that? Circular arrangements of the different objects. So for that, the formula is n minus 1 factorial. So these are all relevant problems. So we are going to see. So in how many ways can 8 people? So that circular permutation direct problem we are going to see. In how many ways can 8 people be seated at a round table? 8 persons are there. So in the circular table, how many different ways they can be seated? So that is nothing but n minus 1 factorial ways they can be arranged. That is 8 minus 1 factorial. So there is 7 factorial ways they can arrange. So there is 7 into 6 into 5 into 4 into 2 into 1. So when you multiply it, you will get as a 5040 as a value. So number of circular arrangement of the n different things when clockwise, anti-clockwise. So clockwise like this, anti-clockwise arrangements are not different. For such a case, in the question, if they have mentioned like that. So here consider if clockwise and anti-clockwise and anti-clockwise arrangements are not different. Such a case, the permutation is 1 by 2 of n minus 1 factorial. 1 by 2 of n minus 1 factorial. So find the number of ways in which n different beads can be arranged to form a necklace. Once again, find the number of ways in which n different beads can be arranged. I mean money, okay, chain, using that beads. When you arrange it in the necklace. So how many different ways you can arrange it? So that is, what is that here? Not n, that n take it as 5. So that is 5 minus 1. I mean 1 by 2 into 5 minus 1 factorial. So that is 1 by 2 into 4 factorial. That is 4 factorial, 4 into 3 into 2 into 1. So 24 divided by 2 is equal to 12. So 12 different ways we can arrange. Here clockwise and anti-clockwise things are not different. Okay, in the chain, when you change the position, whether that is clockwise or anti-clockwise, you don't have different arrangement. Okay, so in the circular, when you think it, if it is the chain, it is in this manner. When you change the position, okay, that means what? Same arrangements will get. So clockwise, anti-clockwise, you cannot mention it as a different arrangements. So here we have to use it, the chain, that is what is it? Clockwise and anti-clockwise arrangements are not a different formula. So there is 1 by 2 of n minus 1 factorial. So it's equal to 12. Each section in the first year of +2 course has exactly 40 students. If there are 4 sections, in how many ways can set of 4 students representative be selected, one from each section? Okay, so 4 sections, so that for missing, we have some, what is that, branch like that, you can also take that. So +2, 4 sections are there. Each section, 1 student representative, we have to choose how many different ways you can choose. That explanation is detailedly given. So 1 student representative can be selected from a section 1 in 40 ways, because each class we have 40 students. Each class we have 40 students. 40 different ways you can select 1 student representative from the section 1. Next, in the section 2, we have 40 students. There are also 40 different ways we can select 1 person. Next, third section, total students 40. So that is one student representative can be selected in 40 ways. Similarly, fourth class, total number of students 40. So student representative, one student representative can be selected in 40 ways. So that is selecting one representative from all these four sections. There is 40 into 40 into 40 into 40. So that means 256, 4 zeros. 25 lakhs 60,000. 25 lakhs 60,000 different ways you can select one student representative from fourth section. Each section consists exactly 40 students. Okay, next problem. Any question? Tell your classmates to attend the class. Only 25 join. Okay, there are 6 multiple choice questions on an examination. How many sequence of answers are possible if the first 3 questions have 4 choices each and the next 3 have 5 each? Okay, total 6 questions, 6 multiple choice questions. In that first 3 questions have 4 choices, next 3 questions have 5 choices. So here the questions, what is that? Either how many sequence of answers are possible? How many sequence of answers are possible? How many different answers, I mean the exact answer can be placed any one of these place. So that is each of first 3 questions can be answered in 4 ways. First 3 questions. First question can be answered 4 ways. Okay. Second question can be answered 4 ways. Next, third question can be answered 4 ways. Similarly, fourth question having 5 multiple choice. In that 5 ways, they can ask it. So, fifth question, 5 options exist. So, 5 different ways they can answer it. Sixth question also having 5 multiple choices. So, you can answer it 5 different ways. How many different answer sequence possible? So, multiple of these all numbers. So first question for into for second question for possible ways. Next question for different ways into 5 into 5 into 5. So that is 8 different answer sequence may exist. That means what is it? All the 6 multiple choice question. So first as a one number sequence, something like first question A, second question A, third question A, fourth question A, fifth question A, sixth question A. Okay, first answer sequence. First answer sequence. Count number 1. Next A, last only B. So this is another answer sequence. So count number 2. Next, first 5 questions answer A, last one as a C. That is another sequence. Like that, how many different answer sequence we can make? That is by multiple of these possibilities. So first questions 4 different ways they can answer. Second question also consists for multiple choice. So 4 different ways they can answer it. Similarly for third question, fourth question, 5 different possibilities. Similarly for fifth and sixth, 5 options are there. So multiple of this values, you will get 8,000 such answer sequence possible. So how many numbers are there between 100 to 1000 in which all the digits are distinct? Okay, from 100 to 1000. So if you take it up 100, 101, 102, 103, 104, 105, like that and so on 1000. In that numbers, no two digits are same. So if you, for example, if you take it up 100, so in that 100, 0 is repeated. So you cannot take it up such a number. Next to 101, so 101 also you cannot take because first and third digit same, so you cannot take. Next 102, So you can take 1 or 2, 1, 0, 2. All these three digits are different. So that is first number having three different digits. Next 103, you can take 104, 105, and so on, 109. Till that you can take that 110. So again you cannot take that 110 because 110. So there is 1 are repeated. So how many such numbers exist? So for that the explanation is given. Any number between 100 to 1000, three digits. Since the numbers should have distinct digits, a repetition of these digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is not allowed. Okay, no digits. What is that? Repeated term is not allowed. Also, 0 cannot be placed on the extreme left place. If 0 is in the leftmost place, it cannot be a three-digit number. If you fix it as a 0, 2, 3, so the 0, 2, 3 is not in between 100 to 1000. Okay, so hence such a number not allowed. So in the 100th place, we can fix it either 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are 9 numbers. So 9 different ways you can arrange the 100th place. Next, 10th place, you can arrange remaining 9 numbers. So if you fix it in the 100th place, one particular number, out of the digits 0, 1, 2, 3, and so on 9. Remaining 9 numbers, you can fix it. So in the 10th place. Okay. So that's why they are putting 9. Next, after 2 digits out of these 10 digits, we fix it. Remaining 8 digits can be placed in the unit place. That's why they put it as a 8. So 9 into 9 into 8. So 648 such a number exists from 100 to 1000. So that means, as I said early, starting with 102, 103, 104, and so on, 109. Next, 112, no. So 113, 114, and so on, 119. Those will not come in this group. Next, 120. Next, 121 will not come. Then 122 will not come. Next, 123. Like that, when you group it such a numbers, 648 such a numbers you can find. Okay. So 100th digit, 9 different numbers you can occupy. The possible numbers are 1 to 9. Okay, 10th place, if you fix it number 2 in the 100th place, remaining 9 numbers. So that is 0, 1, 3, 4, 5, 6, 7, 8, 9. Those 9 numbers can be placed in the 10th place. Next, unit place, remaining 8 numbers only you can fix it. That's why they are putting as a 9 into 9 into 8. So 648 such numbers exist from 100 to 1000. So now next one, a number lock. Okay, the same concept I extend to this, but carefully watch it. So it's simple. So here, a number lock on a suitcase has 3 wheels, each labeled with 10 digits from 0 to 9. 0 to 9. If opening the lock is a particular sequence of 3 digits with no repeats, similar kind of the previous one. So how many such a sequence will be possible? Okay, so here in the leftmost 0 also possible, 0 also possible. So that is on the first wheel there can be 10 digits. Okay, 10 different ways you can in the leftmost. Okay, what is that? 3 wheels are there, leftmost, middle, rightmost. So 3 wheels are there. Here not a 3-digit number, no repeat. No 3 digits are repeated. Such a number is the possible. So how many different ways it can be fixed? So that is the leftmost digits can be 10 different ways you can fix it. So next, in the 10, one number will be there in the leftmost. Next, middle number, remaining 9 numbers. That's why they have put 10 into 9 into next rightmost number as a 8. So that is a 10 into 9 into 8 different ways they can be arranged without repetition of this number sequence. So that is 720 such a numbers possible. Okay, such a possible 3 digits locks you can make. Okay, 9 into 8, 72 into 10. So there is 720 different ways you can arrange it. Any clarification? Yes, find the number of arrangement of the letter of the word. These kind of questions you can expect in the placement interview. You know, some of the companies may ask these kind of questions. So find the number of arrangements of a letter of the word algebra without altering the relative position of the vowels and the consonants. Relative position of the vowels and consonants. Okay, here are the additional conditions given that vowels position should not change. Similarly, consonants position also should not change. So how many such ways you can arrange it? Without any restriction, directly you can take it up. Here, with or without meaning from the letter of the word. For example, how many letters? So that is 7 letters are there. A, L, G, E, B, R, A. So that means 3, 3, 6, so 7. 7 letters without any restriction. How many different permutation you can make? That is 7 factorial ways you can make it. Some of the questions they can make it when you form the word, all vowels are together. Like that they can make. Okay. So different questions. So here, as per the given question, relative position of the vowels and consonant should not change. If one of the things also, if they restrict, automatically other will continue. That means vowels position should not change. Okay, so here, how many vowels and their position? So A, E, A. Okay, see that A, E, A are vowels in the given word. 3 vowels are there and their position 1, 4, and 7. 1, 4, 7. 1, 4, 7 compulsorily should be vowel. Okay, so when you make it the new permutation, in the new permutation, A, E, I mean first position, fourth position, and the seventh position should be occupied by the vowel. Should be occupied by the vowel. Similarly, other position, that means second, third, and fifth, sixth should be occupied by consonants. If you fix the vowels position, automatically vowels, I mean consonants position stable. So those letters will be there in their position. Okay, in their position. So that is 7 letters of each, in which 2 A's and rest are distinct. 3 vowels are there together. A, occupied first, fourth, seventh place. So vowels positions are 1, 4, 7, occupied by any of these 3 letters. Vowels. So how many different ways they can arrange in the 3 positions? That is first position, fourth place, seventh position. 3 factorial ways they can be arranged. In that vowel A is repeat. So if some letter is repeat, you have to divide by that letter as per the given condition. Okay, given formula. So there is 3 factorial by 2 factorial. Okay, that is 3 different ways you can arrange it. So the possible first, fourth, and the seventh place you can arrange it. First arrangement A. First arrangement. Next A. Second arrangement. Next A. Only these 3 possible. Okay, this AAE. Next AEA. Next EAA. So anyhow, these 3 positions are what? 1, 4, 7. Only these 3 possibilities. Okay, this one is first A, this one is second A, not like that. Okay, second A, I'm going to change it as a first A. First A, I'm going to change it as a second A, not the same. So for that, you have to go for this manner. So there is 3 factorial by 2 factorial. So if repeated objects, I mean repeated elements is that, so you have to divide by that value. So that is 3 factorial by 2 factorial, that's equal to 3. Then we have consonants, 4 consonants are there. All the 4 consonants are different, distinct. If they repeat, they are also, you have to use the same formula. That means in the 4, one element is repeat. So that is 4 factorial divided by 2 factorial, you have to put it. Okay, those consonant arrange themselves in those 4 places. What are those 4 places? Second and third and fifth and sixth. Those 4 places. 4 factorial ways they can arrange. And if there is no any repeated elements are there, divide by that. Suppose L is coming twice, so there is 2 4 factorial by 2 factorial. You can put it. But anyhow, in this given letter of the word algebra, no consonant is repeated. So hence that is 4 factorial alone. So 3 into 4 factorial. So there is nothing but 72. 72 such a number of ways you can arrange for this given additional condition. Okay. Any question? There are 5 gentlemen and 4 ladies to dine at a round table. In how many ways can they seat themselves so that no 2 ladies are together? No 2 ladies are together. So, example, I mean the drawing given. So, without any restriction, if they have been arranged in the circular table, that is a total number of person 5 plus 4. Okay. Yes, they didn't take that like that. So here, 5 places without any restriction. Gents can be seated in the place. So that is 5 minus 1 factorial. They can be seated. There is 24 different ways they can arrange. In between only you have to allocate the place of x. So how many x's are there? So that is totally 5 places can be occupied by 4 ladies. Okay, in the X place, you can allocate the 4 ladies. Okay, they can be seated. Hence, they will not be seated together. Okay, in those 5 X place, they can be seated. Hence, there will not be no 2 ladies together. So, hence 5P4. Okay, 5P4. This they can be arranged. That is 5 factorial divided by 5 minus 4 factorial. So 5 factorial is 5 into 4 into 3 into 2 into 1. So 120 different ways the ladies arrange themselves in the round table. Okay. Then multiply with 24, you will get the final outcome. Okay, that is it seems B 2880. 120 into 24. In the screen, it's not visible. Yes, 2880. So for me, it's not sure. Okay. Any clarification? Okay. So in how many different ways can the letter of the word Allahabad be permutated? So here no restriction, but some of the letters are repeated. So that is second condition. Okay. That is Allahabad. In that A repeat 3 times, L repeat 2 times, and A repeat 4 times. Okay, L repeat twice. That's it. So that is 9 factorial divided by 4 factorial into 2 factorial. Okay. Simplify, you'll get 7,560 number of ways. Here, no additional condition added. So based on the additional condition, you have to identify. Okay. So Allahabad, so total number of words are 9. So picking all the 9 letters, what is it? Arrange some word with or without meaning. And here A repeated 4 times and L repeated 2 times. So that is 9 factorial divided by 4 factorial into 2 factorial. So leave that 1 factorial, 1 factorial. Simplify, you'll get 7,560 number of ways it can be arranged. Okay, this one is a big problem. In an examination hall, there are 4 rows of chairs. Each row has 8 chairs, one behind the other. There are 2 classes sitting for the examination with 16 students in each class. It is desired that in each row, all students belong to the same class. and that no two adjacent rows are allotted to the same class. Okay, in how many ways can these 32 students be seated? So two classes, 4 rows. So adjacent rows, not same class students. Such a way that we have to arrange. Each row, 8 chairs are there. So that is 4 rows. Row 1, row 3, first section. Row 2, row 4, second section. Otherwise, what is that? Row 2 and 4, first section. 1 and 3, second section. Like that, you can take it up. Okay. So how many different ways you can arrange? Two different ways they can arrange. Okay, two different ways. Okay. 4 rows given row 1, row 2, row 3, row 4. R1, R2, R3, R4. Section 1, R1, R2, sorry, R1, R3. Section 2, that is R2, R4. That is one combination. Second combination is R1, R3, section 2, R2, R3, section 1. Like that you can do. So two different ways you can arrange the rows. That's what they have put two. That's what it is mentioned. So there are 4 rows of chairs. Say row 1, row 2, row 3, row 4 consists of 8 chairs each. It is decided that each row, all the students belong to the each row belong to the same section. No two adjacent rows are allotted to the same class. Therefore, one class be seated either 1 and 3 or second and fourth. That is in two ways you can be seated. So now 16 students of this class can be arranged in 16 chairs. In the row 1 and row 3, 16 chairs, we have to allocate any one of the section, those 16 students. How many different ways you can arrange? 16p16. That means 16 factorial ways you can arrange it. Similarly, for other 2 rows, arrange 16 students. There is 16p16. That means 16 factorial ways they can arrange. That is 2 into 16 factorial into 16 factorial is the correct answer. So understand the problem clearly. That explanation is given for understanding. You can go through. So next one is combination problem. I think by taking Janagi madam, combinatrix. Combinatrix is nothing but combination. Okay, combination is nothing but selection. Selecting the objects. Selecting the object. That is a combination. Selecting the object, selecting the elements, or selecting the person. Okay, that is called the combination or combinatrix. Here, the difference between permutation and the combination is nothing but selecting the objects. If we take it up the same example, 3 letters, picking 2 letters at a time. So how many different selection possible? How many different combination possible? How many different combination possible? 3 letters, picking 2 letters at a time. So from the letters A, B, C, picking 2 letters at a time. How many different combination possible? Only 3 combination. A, B, then AC, second combination. Next BC. That's it. AB and BA not a different combination. Okay, here arrangement is not a matter. Okay, so here selecting the object AB, BA, both the same selection only. Here, which one come first or second, that is not a matter. Selecting the object, that means AB, BA consider as the same selection, same combination. Okay, so that's what here mentioned. So in how many ways can here students choose program 5 courses if 9 courses are available and 2 courses are compulsory for every student. So it is 5 courses if 9 courses are available. So out of 9 courses, we have to choose 5 courses. 5 courses for the particular year. 2 particular courses are compulsory. 2 particular courses are compulsory. So you can think it, what is that, in the art semester, as for the Anna University, we may have a lot of courses available. So that means the elective also there, that you can think it. So in the 9 courses, here 2 courses are compulsory courses. 2 courses are compulsory courses. So hence, reduce it, total number of 9 minus 2. So that is 7. In the 5 courses also reduce 2 because those 2 courses compulsory you have to select. So hence in the selection, those 2 particular courses, those particular 2 subjects compulsory you have to choose. Okay. So remaining 3 courses out of 7 you have to choose. That's what they have put as a C of 7, I mean 7C3. So that is combination formula NCR is equal to n factorial divided by r factorial into n minus r factorial. What is the formula? NCR. Otherwise, C of n comma r. The formula is n factorial divided by r factorial into n minus r factorial. So as per this problem, n equal to 7, r equal to 3. So 7 factorial divided by 3 factorial into 7 minus 3 factorial. Simplify, you will get 35. Okay, simplify, you will get 35. So those two courses, compulsory courses, how many different ways you can choose? How many different ways you can choose? Only one different way. Okay, only one way you can choose. Okay, otherwise we can take it up for some easy one. So that is in the first semester, mathematics course and English course compulsory. You have to pick out of 9 available courses. Okay, so how many different ways you can choose mathematics and English? Only one way. Okay, so only one way. Those two courses you can choose. Okay, so out of 9, you have to eliminate those two courses, mathematics and English course. I mean technical English course. Omit it, and the 5 courses also the 2 courses eliminated. From remaining 3 courses, you have to choose out of which 7 courses. Remaining 7 courses. So simplify, you will get value as a 35. So this kind of problems come under the what is it? Combination. Otherwise, you can take up selecting the committee, selecting the what is the team. For example, the football team, out of 15 members, select 11 members. For cricket match also 11 players, football also. The available players are sometimes 15 players or 17 players. How many different ways you can select it? So that is 15C11. If you have 17 players, so 17C11 ways you can select it. 17C11 ways you can select it. I'm going to select the one particular person in the different order. I mean, select lastly. So that is not a different selection. Okay, carefully do it. So this combination is in that manner differ from the permutation. Differ from the permutation. So keep in mind. So selecting the team, selecting the committee. Okay, football team or cricket team. Okay, so those kind of problems will come under the combination. So she may have taught. So that's it. Now we move on to the next concept. So a few more problems are there in the permutation. We have to go the next concept. Yes, probability. At least we touched that concept. I mean, easy students may know that. Other the triple and the may not aware of that. Mechanical students. So the concept is very simple only. The probability of the particular event is favor to the case by total number of possible outcomes. So here the probability is mostly these kind of elements. Coin, otherwise a tie. Tie means consisting cube. So that means cube type material. Here in the cube number 1 to 6 printed. So the cube we will have 7 surfaces printed as a number 1. One surface it will be number 1. Another surface number 2. Another surface 3, 4, 5, 6, 7. Like that it will be mentioned. So that cube is here called as a die. D-I-E. Those kind of problems they will take it up. I mean single coin or 2 coins. Otherwise, single die, 2 dice events, picking marbles, picking balls randomly. So those kind of events will come under the probability case. I mean, in the probability, we may use the permutation combination concept here also. Here also, keep it in mind. So they are relevant. Permutation, the calculation will applicable in the probability. And cards game. Okay. Bridge. I mean, 4 different well shuffled cards. Total number of cards, 52 cards. Keep it in mind. 4 into 13. Clever, spade, and diamond. Okay, so 14. So total 4 different cards are there. That means 2 black cards and 2 red cards. Cards based problem they will ask, and you do not consider the joker. Joker is always omitted in the cards based problem. So here one problem is given. The well shuffled card picking. I mean, what is the probability of drawing a king from a well shuffled deck of 52 cards? Okay, so they want to mention 52 cards So we have to choose that total number of cards available in the cards game, 52 cards. Each, I mean, 4 different types of cards there. Each type, 4 different types. Each type, 13 cards will be there. So printed number from what is that? 2, 3 to 10, and ace, king, queen, jack. So total 4 face cards will be there. Okay, 4 face cards. Ace, jack, king, queen. Those are called the face cards. Okay, keep it in mind. Face cards are nothing but J, K, Q, A are called the face cards. Okay, while explaining the problem, you have to know that this concept, these things they have mentioned. So the random experiment. Okay, you cannot use the probability for all the events. These kind of events. So the randomness should be there. So every sample points have equal chance. Every sample points will have equal chance. That means when you throw a coin, you may get either head or tail. There is a possibility of getting tail and get for equal chance. There will be a equal choice. Similarly, for taking the cube consisting 6 surface, when you throw it equal, I mean getting one equally likely to get number 2, number 3, and so on, number 6. Okay. Every surface having equal chance as a top of the surface while throwing the single die. Okay, so those kind of events also events only we can use it. Okay, so random experiments, that's what it is mentioned. Rolling a unbiased dice. Dice means 2 or more. Okay, DIE, single die, that is cube. Tossing a pair coin, drawing a card from a pack of well shuffled cards. Cards, that means 52 cards. Picking a ball containing a certain color from a bag containing balls of different colors. So these kind of events you can take it up. So in that further explanation is given. So that means the cards explanation: spade, glove, 14 diamonds, black cards, red cards. I mean spade and glove, black cards, 14 and hearts are hearts and diamonds, red cards. There are 4 corners of each suits. Otherwise, 4 face cards. These are all the keywords you should remember while forming the question. Sample space. Sample space is nothing but the total number of possible outcome of the random experiment. That is throwing a single coin. The sample points are H and T. Okay, head or tail. So when you throw your 2 coins, the sample points will be H, 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 T, T, H, T, T. So 2 coins when you throw it, you'll get the sample point like this. If you take it up the particular event A, getting 2 tail is our event. How many different possibilities are there? The probability of getting 2 tails when you throw here two coins at a time. So that is 1/4. So total number of possible outcomes are 4. That will come in the denominator. So total number of possible outcome favor to the events. That means TT is our favor to our event, getting 2 tails. So that is 1/4. Like that you have to define. Then rolling a single die. That is the sample points are 1, 2, 3, 4, 5, 6 are the getting what is that? Sample points. Okay, 6. So getting odd number. So the event you can define anyone. That means getting 1 as our event. Otherwise, getting odd number when you throw a single die as an odd number. What will be the probability? What is the probability of getting odd number when you throw a single die? When you throw a single die, getting odd number. What will be the probability? That is odd number when you throw a single die. 1, 3, 5. So 3 elements favor to the case. So total number of cases 6. So 3/6. That is nothing but 1/2. So these are the things. So here P of E as a particular event. So N of E, how many sample points favor to the particular event? So N of S is nothing but total number of the sample points. Total number of the sample points favor to the event. That will come in the denominator. And basic probability you have to learn. So probability of sample point, I mean sample space always 1. And the probability of any events between 0 to 1. Keep it in your mind. Probability of any particular event value lies between 0 to 1. I mean no negative probability are greater than or also a particular event. the probability value cannot be negative value and cannot be greater than 1 also. If you get it, you have committed some mistake. And the probability of empty event, that value is 0. That means that the probability of particular event that is not part of that given sample space. So hence that event, I mean null event corresponding probability is 0. And next two events corresponding union is given. So that is probability of A and B is equal to probability of A plus probability of B minus probability of A intersect B. Set concept you may have learned in the lower classes. And complement concept. So there is probability of A complement is equal to 1 minus probability of A. So if you take it up the rolling a die, okay, getting odd number, event A is getting odd number. What is the probability of not odd number? Is the complement. So that is nothing but 1 minus 3 by 6. That is nothing but 1 by 2. Okay. So you have to understand in that manner. Okay, some other problems you can see. In a simultaneous throw of a pair of dice, find the probability of getting total more than 7. 2 dice. Okay, 2 dice. Pair of dice means 2 dice throw. So when you throw a 2 dice like a coin, so the sample point will be totally 36 different possibilities. When you throw a 2 coin, you may get as a head, tail, head, TT. Like that, a total 4 sample points will get. So, but when you throw a 2 dice, the first die having 6 surfaces, second die consists 6 surfaces. Both when you throw it, on the top of the surface is the win in that game. Okay, so when you throw it, we all know that in the lower class, that I mean Lion, that game you all know that similar kind of that the object that die. Okay, whatever there in the top of the surface is the what is it? Counter. So here, what are the possible? So here the summation is more than that. So here see that the event E that is 2 6. Okay. So the possible sample point is nothing but 1 1 1 2 1 3 1 4 1 5 inside the bracket. Just mention first die 1, second die 1, first die 1, second die 2, 1 2 1 3 1 4 1 6. Next 2, first die 2, second die 1, then 2 comma 2 2 comma 3 2 comma 4 2 comma 5 2 comma 6 and so on. Like that, total 36 possibilities you get it. So here for the event, here when you count it, you have to get more than 7. So what are the samples favor to the case that you can see it in the screen where I kept the cursor. There is a 2 6 3 5 3 6 4 4 4 5. So these sample points are added, you will get more than 7. Okay, so that is how many such elements are there. 15 such elements are there. So that is 15 by 36. So total number of sample points are 36. So 15 by 36, simplify, you will get 5 by 12. Okay. So for the particular probability, what is the total number of sample points that we have to identify? That is n of s we have to identify. For the particular probability event, what is this number of sample points you have to identify? So for this event, 36 is the number of sample points. 36. Okay. So in the numerator, 50 elements have to the case. So it is 15 by 12. So for any probability event, so first, what is the total number of possible cases? Then we have to go for the numerator. I mean, how many favor sample points favor to the our particular event. So you take that the next column. A bag contains 6 white and 4 black balls. 2 balls are drawn at random. Find the probability that they are of same color. Okay, our event is picking ball. The 2 balls are same color. So the picking 2 balls are same color means it can be either those 2 balls are white or those 2 balls are black. So how many different ways you can make it? Without any restriction, we are picking the number of balls. So total 10 balls, picking 2 balls. So 10C2 ways you can arrange it. So the corresponding values, they identify 45 different ways you can pick 2 balls. Okay, total 10 balls from the back. Okay, so next our event is nothing but 2 balls, 2 balls with same color. So those 2 balls either white or black. So how many different ways picking 2 white balls out of 6 2 balls? So 62 ways you can make it. if you pick two white balls, automatically you cannot pick two black balls. Okay, so that is if you get some event, something like that, you have to add up the event. So that is how many different ways you can pick two black balls. That is, we have four black balls. In that, we have to pick two. So 4C2 ways we can pick two black balls. So that is simplifying the calculation. 6 into 5 divided by 2 into 1 plus 4C2 value 4 into 3 divided by 2 into 1. So the formula is what? NCR is equal to n factorial divided by r factorial into n minus r factorial. So using that, you will get value 21. So that is total number of sample points. I mean, numerator value 21, denominator value 45. Denominator value 45. So that is a simplified. You will get the simple version. This one probability you can check. It will not be greater than 1. Greater than 1. Okay. Thank you. Is there any doubt we may discuss with you? Any question, any clarification? I am ready to answer your questions. That's what we can do. So if we get time in the future, we'll discuss more problems related to this concepts, probability concept. You may refer, you all have that Agarwal book, aptitude, mathematical aptitude. What is it? Agarwal, R.S. Agarwal. Otherwise, you have a lot of books available in the website. You can download and use soft copy. Okay, competitive exam questions also available. You can use it. Thank you, Bob. Is there any question you can discuss with me?